quadratic function. So all that work we did on quadratics comes in really handy when we start graphing them. So a quadratic function gives us the shape we called a parabola that we talked about before. And some of the things that we can tell straight away. So if our function is given to us in this form, so ax squared plus bx plus c, if a is greater than 0, the parabola is concave up. So what that means is that concave up, the shape is going to look like this. Okay, so the way to remember it is that a positive A is a happy face. And yes, I know it sounds silly, but it's the easiest way you've got for remembering this. Okay, and if A is negative or less than 0, then it is concave down and you get a sad face parabola. This question, they want us to sketch y equals x squared minus 4, showing the intercepts. We then have to state the domain and range. So think about what this is telling us. Y equals x squared minus 4, and we need to find the intercepts. First, let's say y is equal to 0. That's going to help us find the x-intercepts. We're going to end up with 0 equals x squared minus 4. And this is why we did all that factorizing, because then you should be really quickly able to say, well, hey, that's just the difference of 2 squares. And so I factorize it to x plus 2, x minus 2, which means quite obviously that x is equal to plus or minus 2. The other intercepts that you need to think about is when x is equal to 0. So y is then equal to 0 squared minus 4. So the y-intercept is minus 4. So you have 3 points there. You know, looking at that equation, x squared minus 4, well, the a, the coefficient of x squared, is positive. It's 1. So this is a happy face parabola. It is a concave up parabola that goes through the points y is equal to negative 4, x is equal to plus 2, and x is equal to negative 2. So let's mark some of that information onto our graph. We know that the x-intercepts are 2 and negative 2, and we know that the y-intercept is negative 4. We know, looking at our equation, x squared minus 4, that this is concave up, and they're the places where it crosses through the axis. Now, a parabola is a symmetrical shape, so if it goes through negative 2 and 2, then it must turn at 0. So that point on the y-axis is also the turning point of our parabola. So we come down through that point, turn down there, and then head back up there. Now, as you can see, I am not the best sketcher, but you know what? It won't matter. When you're being asked to sketch this, you've shown your intercepts, you've got a parabolic shape, and it's all symmetrical. So that's the first part. So we've sketched it and we've shown the intercepts. So then we need to state the domain and the range. So the domain for our parabola is all real x. Range, well, have a look at that graph. The lowest point that y gets to is negative 4. So we can say that our range is y is greater than or equal to negative 4, because we know that negative 4 is the minimum value for our parabola. Okay, so this one's been given to us in a slightly different form. They've already factorized it. Y equals x plus 2 all squared. So it's going to be a similar parabola to the last one, but in the last one we had x minus 2, x plus 2 as the factors. For this one, we just have x plus 2 for both factors. So what's that going to mean for our parabola, do you think? All right, well, let's go back. It's already factorized, so it's very easy for us to substitute in y is equal to 0. We get 0 is equal to x plus 2 all squared, and that can only happen if x equals negative 2. So we only have one solution for this one. So what does that mean for our graph? Well, that means that it doesn't cross through the x-axis. It only touches at that point x is equal to negative 2. There's only one root for this equation. The last equation had 2 roots. This one only has 1. Now let's look at the y-intercept. So the y-intercept is when x is equal to 0. So if we substitute in x equals 0, we're going to get y is equal to 0 plus 2 all squared, so you get 4. So it crosses at 4. So that -2 is your minimum value. That's as low as y is going to get. It doesn't cross the axis. We know that because it doesn't cross a second time and parabolas come back up. It only touches at that point and it goes through 4. So if it goes through 4 at -2, that means it's going to go through 4 again at -4 because parabolas are symmetrical. So we've got a few points. Draw your parabolic shape through those points. Hopefully your drawing is going to get better than mine. Only 2 intercepts to find for this parabola. So this question is very different. We're given a quadratic function and we are asked to find the intercepts, find the minimum value, state the domain and range, and then answer the question for what values of x is the curve decreasing. So decreasing means is it going down? The difference here though is that we haven't been asked to draw a graph. A lot of students therefore won't draw it. And while you're not going to get marks for drawing it, having yourself a little sketch is going to make answering some of those questions much easier, especially domain and range and the decreasing question. So once you've got the information from the intercepts and the minimum value, I would do yourself a small sketch anyway. So let's have a look. We need to find all of the intercepts first. So if we're first going to find the x-intercept, we'll substitute in y is equal to 0. So if I substitute in y is equal to 0, I get x squared minus 7x plus 12. So factors of 12, that will give me a -7, a -4 and -3. So this factorizes to x minus 4, x minus 3. Which means that x has to equal 3 or 4. So there are intercepts on the x-axis. For the y-intercept, we substitute in x is equal to 0. So we get f of 0, 0 squared minus 7 times 0 plus 12. So y is equal to 12 is your y-intercept. Okay, now part B. We're asked to find the minimum value. Anybody have any ideas on how to do that? Okay, so we know that it crosses at 3 and 4, and a parabola is symmetrical. So if it crosses between 3 and 4, it goes like this. Well, where's the minimum value going to be? Halfway between 3 and 4. So the minimum value is between 3 and 4. It's at 3.5. So we know where that occurs, but we don't know what it is. Knowing that it's at x equals 3.5 doesn't answer the question. What is the minimum value? For that, you need to substitute it back into the equation. So when you substitute that in, you get minus 0.25. So the minimum value is -1/4. So part C, we're asked to state the domain and range. Well, again, this parabola, concave up. The domain is all x. Now the range, and this is why you had to do part B, because you needed to find out what that minimum value was. So the range is y is greater than or equal to -0.25. Now for part D, we haven't looked at a question like this before, but for what values is this decreasing? So decreasing function means what? Well, it means that the values are getting smaller. So this is a decreasing function for everything up to x is equal to 3.5. So for what values of x is the curve decreasing? Well, it's decreasing for all x is less than or equal to 3.5. So up until 3.5, this function decreases, and then it starts increasing. So that's what you need to do exercise 5.5 I want you to do at least half of it, so every second question, okay guys? But make sure you mix it up. Don't do all the ones that are identical. Try a few new things.